last video for this class this semester. Holy guacamole. So happy that you made it. We just have the Excel project and then a final exam, and then we are home free. All right, so let's go ahead and take a look at this Excel project. Now, you are allowed to work with other people if you want to on this project, up to 2 others for a total of 3. Just make sure to put their names in these boxes. This particular Excel project has 4 tabs. Most of the work is going to be done right here. We also have present value tables, single sum, and present value of an annuity table here for easy reference. Now, I have the instructions listed out here, so those should be very helpful. And then, but essentially, here's the order of operations: is we have a company that wants to expand and have a new product line. And so they're looking between 3 different alternatives at which product line that they want to go forward with. So we're going to we're basically going to calculate NPV using 2 different methods. Once in the same way that we've been doing up through this point. It's great practice for the exam. I want you to get in the mindset of doing it this way. But then, because Excel is so awesome, I want to show you how Excel calculates NPV as a formula. And so that will be part B. And then, oh no, I'm sorry. That's parts A and B are the first part. And then part C is the formula part. Once you get that completed, I have some thinking questions for you, some analysis questions, so you can look at the data and determine, what it means. And then at the very last part, this was actually part 4. Just spotted something. Anyway, so, and then on the very last question, it asks you to input a salvage value. So you'll go back into your calculations from above and then see how things change with a salvage value. So let's take a look at this. So here is your spreadsheet. This is what I want you to be working in. The interest rate, and then will come directly from the prompt in the instructions. So you can just enter it right here. It happens to be 4% this semester. And initially the salvage value will be 0, although that will change in the very last step of the problem. Now, when you're dealing with these 3 investment alternatives, these are the revenues expected, the revenues expected to be brought in from this product line is a plant-based meat substitute. So your revenues can be thought of as cash flows. Your expenses can be thought of as, revenues are inflows, expenses are outflows. And so we need to determine the net annual cash flows. So that is going to be the net of those 2. We can go ahead and bring that down. I'll take some totals for each of these lines, and we can bring those over. So once we get that information in there, we can use it to do our NPV analysis the way we've done so far. So in these set of yellow boxes, you might not use all of them for each calculation, but I gave you lots of room to put out whatever cash flows you want. So when you're looking, even though, in this case, the revenues and the expenses are exactly the same, so it would kind of indicate that. But really, I want you to look at the net annual cash flows, and that's going to determine whether or not you have an annuity. So in this case, you have this $450,000 in every single year, an amount coming in every year. So this would be considered an annuity. And so I'm going to just do the first one here. So because of that, I am like, okay, well, I know I can use kind of my shortcut in doing in using the annuity. So I'm just going to call this like cash flows years 1 through 5. The cash flow, I'm just going to choose the single annual cash flow right there. And then because I have recognized that this is an annuity, I'm going to use the present value factor from the annuity table. The interest rate is 4%. And in this case, N equals 5, because when we have an annuity, we want to know how many times is this payment happening, for how many years. So it happens for 5 years. So we'll use N equals 5 for this particular one. So N equals 5, I equals 4, and there it is. So now the present value of my cash flows is going to be the cash flow times the PV factor. And remember that this $2 million, this isn't the present value of $450,000. This is the present value of $450,000 happening 5 times. So it's like 5 times 450. But you don't have to do that math here. The present value factor does that math for you. But this is considered one string of cash flows. So I've got that in there. So now I'm like, okay, well, what other cash flows are happening in this particular problem? Well, we also know we don't really have anything more complicated, like, anything you have to net out or figure out, or, any one-off type of a cash flow. But is the NPV of this really $2 million? No, because I haven't included my initial investment yet. So I'm going to throw in my initial investment, and I'm going to make it negative to indicate that it is an outflow of cash. So if I do that value there, that is my cash flow. When is that happening? That's happening now. So what is the present value factor for anything that's happening today? Well, the way that if a student comes up and asks me this question, I always ask them, well, what is the value of $2 million today? If I was to give you $2 million, what would be that? What is that worth to you? And the answer is it's worth $2 million. $2 million today is worth $2 million. So the present value factor is the thing you need to multiply $2 million by to get $2 million. So anything that's happening today, the present value factor is 1. So I can pull this formula down. And so now I can see, that this is my NPV. And even though I don't have a salvage value right now, this is where I would input one if I did have one. So if I have a salvage value, then it would be equal to whatever is here, right? And what would be the present value factor for this particular cash flow? Well, is a salvage value an inflow or an outflow? That's the first question. And the answer is it's an inflow. And the reason is because we expect to sell off this equipment at the end of its useful life. And and at that time, this is the money that we expect to bring in. So that is just a single cash flow out in 5 years. It's not a cash flow that we're going to receive. We're not going to receive the payment for the equipment in years 1, 2, 3, 4, and 5, just in year 5. So that cash flow called the salvage value is going to use the single sum present value table. And we're doing it for N equals 5 and I equals 4. So that's the one we're going to go with. And my present value right now is 0 because it's taking 0 times this present value factor, which is still 0. But if I had, a different value in the salvage value, then that would change everything. And everything's going to have the same salvage value. So I just have you inputting it here. And then I have formulas that say, okay, well, these are going to equal this. So you don't have to input these. Don't mess with that. Just mess with this value right here when the time comes. In the beginning, it's 0. Okay, so that is how you would complete this table and these tables. Now, you're going to have to see if this string is a string of cash flows is an annuity, or if it's single different cash flows every single year. And if that is the case, you're going to have to put 5 different cash flows and or years 1 through 5 different cash flows, whatever these are, if this is not an annuity, hint hint, and then 5 different present value factors, n equals 1, n equals 2, n equals 3, 4, and 5. And those are all, and those, assuming it's not an annuity, those would all be the single sum table. Calc it out the same way. Make sure to include your initial investment and someday, but not right now, your salvage value, and that will equal your NPV. And that's how you do it on all of these. Then, after you complete these pieces, the next step is to use the NPV formula in Excel. Now, I wanted you to practice this because this is the way that we do it in the exam. So it's really handy skill to have, but Excel is really awesome. And so it'll help with a bunch of calculations, and it might do it a little bit faster if we were just going that route. So what I would then do is instead I would use this NPV formula. However, you kind of have to know what Excel believes when you're setting